After the label fell off a bottle containing a clear liquid believed to be benzene, a chemist measured the density of the liquid to verify its identity. A 25 milliliter portion of the liquid had a mass of 21.95 grams. A chemistry handbook lists the density of benzene at 15 degrees Celsius at 0.8787 grams per milliliter. Is the calculated density in agreement with the tabulated density value? Well, let's see. So if we take the mass of the sample divided by the volume of the sample, we get the density of the sample, and I'd say that's pretty close to what the established label says. So good enough, right, at 3 sig figs. B, an experiment requires 15 grams of cyclohexane, whose density at 25 degrees Celsius is 0.7781 grams per milliliter. What volume of cyclohexane should be used? All right, so again, we're using the density of cyclohexane as a conversion factor to go from grams of cyclohexane to milliliters of cyclohexane, right? So the unit we want to get rid of is grams, that goes in the denominator, and the unit we want to get to is milliliters, that goes up in the numerator. 3 sig figs in this answer. C, a spherical ball of lead has a diameter of 5 centimeters. What is the mass of the sphere if lead has a density of 11.34 grams per cubic centimeter? All right, and they give us the formula for using the radius to find the volume. So this is the same problem, C. It's just, got a fancy way to find the, well, not fancy. You have a way to find the volume of the sphere, right? So you plug in the radius of the sphere into converting to volume of the sphere, and then we can use the volume of the sphere and the density to convert to grams. 2 sig figs in this answer, right? Yeah, we had a 2 sig fig side measurement, so it ends up being a 2 sig fig answer. 33, indicate which of the following are exact numbers. All right, so exact numbers versus measured, right? So with sig figs, guys, it's all about measured values. There are no sig figs with 3 pieces of paper is not is not how many significant figures in that number. It's only what does 3 pieces of paper weigh? So what is the mass of 3 pieces of paper would be a measured value. The volume of a cup of coffee would be a measured value. A pound, I guess is definitional, right? So that's an exact amount. D, number of ounces in a pound. Again, that's a definitional thing. That's an exact amount. Number of microseconds in a week. Now, this is a weird one. I had to look this up. You measure how fast the Earth goes around the sun, right? And how fast it spins on its axis. So they call this a measured value. I don't know. It'd be a kind of a hard one. I look at it as kind of definitional myself, but they say not. Number of pages in this book is an exact amount, not a measured amount. So again, it's all, with significant figures, it's all about measured values. So it's glad with this problem they put in units. So how many sig figs in each of these measurements? Well, to the nearest kilogram there, so we got 3 sig figs in the first measurement. To the nearest 10,000th of a second. Now, those first 2 digits are just space holders. We didn't start measuring anything till we got to the 100th of a second. So there's only 2 sig figs in this measurement. If you're reporting all the way out to the 10,000th of a centimeter, that means there's 5 sig figs in this measurement. Again, all the way out to the 10,000th of a liter, 3 sig figs, right? Good, that's right. We had space holders, right? We weren't measuring anything until we got to the nearest 10th of a liter. Written in scientific notation, they're telling you all these numbers are significant. So 5 sig figs in this measurement. And, I didn't put the unit in, right? So the cubic meters. And ambiguous here. It'd be nice if they had a decimal point. I'm not sure if this is the nearest gram or not. It'd be nice if they had put a decimal point. Then it's like, oh, okay, so the nearest gram, 3 sig fig measurement. So let's say it didn't measure to the nearest gram. Let's say it measured to the nearest 10 grams. In order to show that, we'd have to write it in scientific notation to have a 2 sig fig measurement. So significant figures. Round each of the following numbers to 4 significant figures and express the result in standard exponential notation. Oh, I don't know. I didn't do this. I think I did it in, oh, exponential notation, right, scientific notation. So good. 4 sig figs. So we look for the last reportable digit. If we're looking at A, the last reportable digit is the 5. It's followed by a 3, so we leave it alone. We don't round it up. We just drop off what's not significant. We want 4 sig figs here. We're looking at that 9. It's followed by an 8, so we'd round that up. And we'd have to put this in scientific notation, right? There's only 4 sig figs in this measurement. So we'd have to move the decimal place and write it in scientific notation. Again, we're looking at the 2 in, no, is it 8, 5, 4, 3. We're looking at the 3. The 3 is followed by a 2, so we just leave the 3 alone. Again, we'd have to write this in scientific notation to give me 4 sig figs. It's 4 sig figs, 4 sig figs. Carry out the following operations and express the answer with the appropriate number of significant figures. All right, so we've got adding versus multiplying, right? 2 different ways of doing, calculating with significant figures. So when you're adding 2 things together, you look at the degree of accuracy. Measurement number 2, the 2.56, is only measuring to the nearest hundredth of a gram. So my answer would have to be represented to the nearest hundredth of a gram. So this was out of the book, right? The last report, the least accurate measurement, right, was to the nearest tenth of a gram. So you'd have to round to the 8. In hour 1, we'd have to round to that 0. So that would be the correct answer. Same thing with subtracting. We look at the least degree of accuracy. So our first measurement only goes to the nearest tenth of whatever. So we round to the nearest tenth. C is different. This is multiplication. In this case, you just look at the number of significant figures in the measurement. So 4 sig fig measurement multiplied by a 4 sig fig measurement. My answer would be in 4 sig figs. All right, so going back to problem 8. If we want to find the volume of this box, and we're trying to get the sig figs right, the least number of sig figs was measured on the width. So I'd have to express it in 2 sig figs, right? So 2 sig figs times 3 sig figs times 3 sig figs. My answer could only be expressed in 2 sig figs. And that's how we deal with multiplication. It's kind of easier. You just look at the number of sig figs and in the measurement, and you reflect that in your answer. So back to, we wanted to report the density. How many significant figures? How many significant figures should be reported when its density is determined using the calculated value? Okay, so they gave us a 2 sig fig. We figured out that we had a 2 sig fig volume. We had we're dividing into a 5 sig fig mass. My answer can only be expressed in 2 sig figs. So you'd have to round to 2 sig figs with this one. So back to our question C, 4 sig. All right, 3 sig figs, right? So it's a 3 sig fig times a 4 sig fig. What happened? Did I do something wrong? Go back. Boom, 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 boom. Just real quick. Yeah, I wrote it in wrong. It's the wrong number. Huh, I must have borrowed from somewhere. Quick, sorry, my bad. Just gonna change it. Hang in there, people. Hang in. Better. 3 sig figs times 4 sig figs. Your answer comes out to, all right, go through all this, right? 2, yeah, okay, good. 3 sig figs, good. So with the next one, let's see if we got the numbers right. So a 3 sig fig measurement divided by a 3 sig fig measurement, my answer would be in 3 sig figs. And that's how we deal with calculating with sig figs. 45. A bumblebee flies with a ground speed of 15.2 meters per second. Calculate the speed in kilometers per hour. All right, so this is again, we won't deal with bumblebees in this course, but this is just practicing unit conversion. So whenever you're converting from one unit to another, right, meters per second to kilometers per hour, the first thing you do is write down what's given. So for every 1 second, you're moving 15.2 meters. So then we start looking for conversion units. How do I go from meters to kilometers, and how do I go from seconds to hours? Okay, so again, it's unit conversion, right? Dimensional analysis. Whatever unit I want to get rid of goes down the denominator, and whatever unit I'm trying to get to goes up in the numerator. So, all right. So for example, what is the fraction by mass of oxygen and magnesium oxide? So a little, going off topic here, but guys, if I divide 16 grams, right, by 40.03 grams, what I'm going to get is grams over grams. So when I do a percentage, the units cancel. A percentage is or a fraction is unitless. So there is no, unit with a fraction. So in this situation, if I want to go from seconds to minutes, I put seconds up in the numerator in this case, and what I want to convert to down the denominator in the denominator. So I want to end up with hours down the denominator. So when I multiply across seconds would cancel, minutes would cancel, and I'd have hours down the denominator. Well, I want to go from meters to kilometers. So the conversion factor is for every 1,000 meters, you got 1 kilometer. In this case, I want kilometers up in the numerator. So, and canceling meters down the denominator. So when I multiply across, everything cancels, right? Minutes cancel, seconds cancel, meters cancel. I'm left with hours per kilometer. So calculation-wise, you just multiply the numerators and divide by the denominators. So 15.2 times 60 times 60 times 1 divided by 1 divided by 1 divided by 1 divided by 1,000 gives me how many kilometers I would have moved in 1 hour. So that's dimensional analysis. B, the lung capacity of a blue whale is 5,000 liters, right? 2 sig figs. Convert the volume to gallons. Oh God, we never use gallons. I have to go on the internet to find that conversion factor, right? So put down what's given. I'm given liters. I want to get to gallons. I look on Google, find myself a unit converter, and convert. How many liters are there in basically 1 gallon? Use that as my conversion unit to go from liters to gallons. I want gallons. I want to cancel liters, so that goes in the denominator. Gallons up in the numerator. So a lot of gallons. Blah, blah, blah. C. The Statue of Liberty is 151 feet tall. Calculate its height in meters. Okay. I don't know. Did I do this one? I think I stopped here. I don't think I did C. Oh, I did do C. No, what did I do? Huh. Oh, I skipped C. That's the problem. I'm sorry, guys. We're calling it D. Let's just turn it around. I skipped C. Let's put a little line here. Shape. I'll put that right there. We're not doing C. Just give it up. Format. Yeah. Let's make it. Style. Let's make it thicker line. Bring it up. There we go. Give it a C. Oh, sorry, guys. Back to the program. I am looking at D. Bamboo can grow up to be 60 centimeters per day. What? Wow. 60 centimeters in a day. Convert this growth to inches per hour. Wow, that's a fast-growing plant. All right, so I want to go from this ratio of centimeters per day to inches per hour. All right, so I look up what the conversion unit is to go from centimeters to inches. 2.54 centimeters for every 1 inch. I want to get inches up in the numerator. I want to cancel days. I want to get it to hours, right? So I need a conversion factor to go from days to hours. In this case, I want hours down the denominator, so days up in the numerator. So when I multiply across, I will have converted to inches per hour, right? That's the unit I'm left with here. So multiply the numerator, 60 times 1 times 1 divided by 1 divided by 2.54 divided by 24 gives me how many inches you'd go in 1 hour. Wow. Fast growing. I guess you can hear it.